In today's tutorial, we're going to try to create an invisibility effect on our character where he can completely disappear and just turn into a shadow and sort of roam unseen amongst the enemies around him. And then when he finds a safe position, he can just reappear again. And we can also control that effect manually. So we can show it, and we can even just hide part of the mesh there if we wanted to. So in today's tutorial, we're going to try to recreate this effect. In this tutorial, we are using the default third-person template. So I've taken the third-person character and copied it across here and just renamed it as our BP Ninja player character. We'll open that first, and I'm going to change it to a character that I've downloaded from Mixamo. So that is this ninja character with 2 animations and a simple animation blueprint that I've created. So if we set that up first, so the skeletal mesh we can change to our ninja skeletal mesh, and we can change our blueprint to the ABP ninja, and then we just need to maybe get him into the actual capsule himself. The effect that we're going to try to create today is that the invisibility effect will start first of all from the head and go vertically down to the feet, and then we'll also add an ability to control the opacity of the actual mesh inside. And when that mesh is completely invisible, we'll have it just show the shadow of the ninja. And in order to create this, the magic will all be in the actual material itself. So in this character, if you go into the mesh, there is just one material here. You may have a character with multiple materials, in which case you might need to add this effect either to the main material or to each of the materials being used. If we just go and find this material in our content browser, and if we duplicate the original and just rename it maybe Ninja Invisible, and then we can open that up. And this is the default material that is creating the skeletal mesh material at the moment. In order to create an invisibility effect, we'll need some element of translucency. So there are 2 options. At the moment, if you click on the main node there, the blend mode is opaque. We can either use masked or translucent, and there will be differences in both. So if I click on translucent first, you notice that we get a base color, but we lose all the metallic specular. We get an opacity value. And the other option we can get in the translucency is a refraction method, so an index of refraction. And that allows you to create an effect of the light bending. On the other hand, if we create a masked material, we get all the metallic specular back. The opacity gets replaced by an opacity mask, but we lose the refraction. I think in the effect that we want to create today, the opacity mask will probably be the more beneficial. In order to do this, because we want to be able to control the values, we should probably create a material parameter collection. So if we go to material and go to material parameter collection and call that MPC Ninja, and just open that up, we'll want 2 scalar parameters, I think. So the first one will be for the sort of vertical opacity. By default, that will be 1, so it will be fully opaque. And the second one will be the sort of the mesh opacity or the body's opacity. And again, by default, it will be fully opaque. Then if we go back to our Ninja material, You notice that there is an opacity mask here. Now you can just change the number there. So if we have a look what happens, I mean, first of all, let's just put our correct material on our character here, which is material Ninja Invisible. And if I've added the character to the scene here. If I go and change the value to 0.5 and apply, nothing is obvious, but there will be an opacity being added that will be added to the entire mesh itself. Because if I go even lower to 0.3, completely disappears. So in between those two numbers there would be some opacity. However, we don't want it to be a uniform opacity. We want there to be some kind of variation in there. So the easiest way of doing that and adding translucency to a masked material is by using a dither node. First thing we'll do though is we'll get access to our collection parameter that we've created, which was the NPC Ninja. And if we get the mesh opacity first, and then if you look for a dither node, so this dither temporal AA, and the way that this works is if you click on it, it says it will create a stipple pattern in screen space. In other words, it will almost create holes in the mesh itself so you can see through it, which creates a translucent effect. And what we want to do is we need to feed a number into here. So we'll feed the mesh opacity into here. We also want this dither result to be 0 when the opacity is 0. So we should multiply what comes out by that result. And then we can put that into the opacity mask. And if we apply that, and then go to our default value here, and to the mesh opacity, if we just maybe put 0.56 there, save it, you notice that we now get this kind of effect where there's a stippling pattern, so every other pixel is almost translucent, and that creates an effect like this. So we just play it. Instantly we've got this kind of invisibility effect where you can see through the character. So that dither node is particularly useful if you want translucency in a masked material. If we want to create an effect where this opacity starts from the top and works its way down instead of being applied to the entire mesh from the start, we'll need to know certain things about this mesh. So we'll need to know the Z position of a pixel so we can compare it to a line that is moving down. Now we've set up something in our material parameter collection. We called it vertical opacity. This is probably better written as being that vertical line which will pass downwards from the top to the feet. So we could say the vertical line location, and that will be between 0 and 1. So it will start from the top and work its way down from 1 down to 0. So how do we get the vertical position of a pixel in this mesh? So if we go back to our material, the node that we will use is called a bounding box node. So a bounding box based 0 to 1. The way to think about this is that if this is a mesh, you could draw a bounding box around it, and that box will have an X, Y, and Z coordinate. And what this will do is it will align that coordinate between 0 to 1. So you can then identify what the Z coordinate of any pixel is in that bounding box. And what we will do is the way it works is that RG and B refers to X, Y, and Z. We want the Z. And we want to take the Z and we want to minus a value from it. The value that we want to minus is the one that we will be changing in our material parameter collection. And that is the position, if we find it again, of the line location. So we'll take the Z of the pixel in the bounding box, we'll minus the vertical line location. This will give us a fractional value between 0 and 1 because both of these numbers are between 0 and 1, and it could be negative. So we'll seal it. What that will do is that anything that is above 0 will become 1, and anything that is 0 or less will become 0. That means that we'll get a value between 0 and 1 coming out of here, which we can then use in a lerp. So that can be our alpha value for the lerp. As this value will be either 0 or 1, we know that if it is 0, i.e. it is below the line, we want to just show a normal opacity of 1, so we want there to be no translucency. If it is above the line that is moving down, we want to show this as being our opacity. So we can lerp that. We can maybe call this a named reroute and just say this will be our mesh opacity mask. And then to begin with, we can put that into the opacity mask. And we can apply that. So once it has been applied and saved, we go back to our character, and if we take our MPC that we're using here, and what happens when we start to bring this value down? So as you can see now, there is a vertical effect that is working on it. So it will go from 1 and all the way down to 0 when this opacity will then be the one that is shown. And we can change that to make it more or make it less. And this will control the line at which it is working. Now when it goes down to 0, the shadow disappears, as you can see. So if we just put that halfway there, and if we just play, so we do get that effect there with a vertical line to where the translucency is being shown. And the translucency affects the shadow that's being cast on the ground. We now have control over the mesh opacity using these nodes, and by using the bounding box, comparing it to a vertical line location, we then have that vertical opacity. And when we combine the two with a linear interpolate, we then get our final mesh opacity that we're looking for. What we now need to do is somehow control the shadow. So as I said in our original intro, we want to have an effect where when the opacity becomes 0 and the character disappears, we just see the shadow being cast on the ground. The issue with the shadow is that when the mesh is invisible, so when the opacity goes down, obviously there is no light being cast, so no shadow is being shown. So we need to find a way of showing a shadow when the mesh is invisible. At the moment we are just controlling this with our material parameter collection, so it would be probably worth starting off by just adding an automated way of doing this with a key press. If we go back to our Ninja character, and down here if we create a debug key to activate our invisibility, and we'll use debug key I, we'll need a timeline because we need to control certain values here. So our vertical line will be 1 by default, and our opacity will be 1 by default, and we want to control these with an animation. So let's just save those numbers, and we'll create a timeline. This will be our invisibility timeline. And we'll add maybe two tracks to this. So the first one will be the vertical line position. And we can just press Shift and click to create a first key. That will start off at 1 and go where it will be. It will start off at 0 time where it will be 1. And then we create another key. And should we say over 1 second, it will go down to 0. We can create another track, another float track, and we'll call this our opacity, our mesh opacity. Shift and click, and we'll maybe start that with a bit of a delay. We can play about with that, so we'll say maybe 0.5 seconds. It will start from 1. And then we can click again, and we can say again at 1 second it will maybe go to, I think, probably 0.35. It will probably be invisible by that point. And this will just be a 1 second timeline. So we go back to our event graph, and now we will get these values on the update. So we want to set them in a material parameter collection. So we can say set scalar parameter value, and this will allow us to access our material parameter collection, which is the MPC Ninja. And we can choose the parameter name, vertical line location. The vertical line will be this parameter. We can grab this, we can duplicate it with Control D, and this will put this as the mesh opacity. So this float track can set this value. And when we press, we'll just put a flip flop so we can go forwards and backwards. So that will start from there, and this will reverse from the end. We can test to see whether that works or not. So I'll press the I key and we completely disappear. Press that and we kind of come back. The issue, as we can see though, is our shadow disappears. So if we go back to our Ninja character, you'll notice that there are quite a few options you have available here. So if you type in shadow, you can decide whether it casts a shadow, whether it's a dynamic shadow, how it does a self shadow just on itself or a far shadow. But there is also an option here to show a hidden shadow. So this will cast shadows even if it is hidden. So we could try to maybe begin by taking advantage of this and see how that looks. So when it comes through the update and it finishes the update, we can just check to see which direction it's moving in. So we could switch on that, and if it's going forward, so it's going from visible to invisible, we can maybe show the shadow. We could put this in its own custom event. So we'll say make invisible. From here we can decide whether the actor is hidden or not. So we could say set actor hidden in game. And if we go back to what we've found here, there is an option to say hidden shadow. So if we click that to be true, then when we set this to being hidden, it should hopefully show just the shadow. So on the finished update here, we call make invisible. If we go back to our map and we play that, and I press I, so it disappears, but not showing the shadow. The reason for that is that our opacity is actually 0, so no shadow would be shown. And to see why that is true, we just change the opacity. Basically at this point nothing is visible, so I put that at 0.45 and then do this. So I then press I. We do see a bit of a shadow there, even though the mesh is not visible. The intensity of the shadow is tied to the opacity of the mesh, even though the actor is hidden. So if we want it to be a lot more visible than what we're getting at the moment here, we'll need to increase the opacity when it is hidden. So if we go back here, so at this point when we hide the actor, we'll need to put the opacity back up towards 1. So we can maybe just create another custom event and call this opacity change. And maybe create another timeline to do this. So timeline, there, and this will be our opacity timeline. So in this one we'll create a track, again a float track, let's call that opacity, and we'll go from, I think it starts off at 0.3, we'll start it off at 0.35 at 0, and maybe at 1 second we push it back up to 1. And we can kind of put some effects in here so it goes up and down once we know that it's working. And go back to our event graph. So opacity change, we can say play from start. We can set the scalar parameter of that same collection, this time just the opacity. Put that there and put that on the update. So when this happens, we can call opacity change. See whether that makes our shadow easier to see. So press I, and now we get that effect. Let's just do that again. So press I, we become invisible, and then our shadow appears. We don't want any collisions while we're walking around, so let's just get rid of that. Click on our camera boom and look at do collision test. Let's turn that off. So when we are invisible, basically we can just walk around without any collisions with our camera. The issue now though is that once we've made the opacity to go back to 1, we've got an issue when we want to reverse it again. So we want a way of being able to show the shadow even when the opacity is at essentially close to 0. And we might need to take advantage of a node that's available in the material function or the material itself. Before we go to our material, let's just make this a bit more clearer. So this is opacity change when becoming invisible, because we might want to reverse it when we go the other way. So when it finishes, we can just maybe do a switch on this direction and just set that up. Switch on the timeline direction. So that's the basics of that. Now if we go to our actual Ninja and look at this node that I'm talking about. In the material, if we want to get access to just the shadow of this material, there is a node in here called a shadow pass switch. I think the way that works is that you put in what the default shadow should be, and then you give it a mask known as the shadow. So we could say, for instance, the default shadow would be based on this. So we can just Control D that. And this value here can either be a 0 or a 1, and this forms the mask. So you can use this to give an object a shadow that is different to the one it should cast based on its shape. So I just create a scalar property here, and this is just as a test. This can be a 0 or a 1. And if we take our mesh opacity that's coming through, and maybe we just subtract this value from there and put it in, and then we apply it. So when it's 0 and we then play, we get the shadow being shown. If we put this as being 1 and then apply, now we just get our character without a shadow. So we can try to take advantage of this. What we'd normally do is just use the alpha in here, which should give us our shadow. Okay, again, cause the same effect for it to disappear. So if we remove this, I think, and in the shadow pass, this should give us the actual shadow itself. We can maybe just put that as a named reroute, say shadow only. So this will be the mask just for the shadow itself. And then we can create a lerp to decide what we actually show, whether we show the mesh or we just show the shadow. So we go back to our MPC Ninja. We can maybe create another scalar parameter and call that sort of shadow only, and put that as 0 to begin with. And then in our material again, we can maybe do another lerp. This time we can get hold of our collection parameter that we just created on the MPC Ninja, and that is the shadow only value. And that will be what we lerp on. So that should be a 0 or a 1, which we'll set in the blueprint. If it's 0, we want to show the mesh opacity. And if we set it to 1, we want to show the shadow only. We can then connect this up to the end opacity that we're putting through. Apply that. So nothing should change to begin with. That's all working fine. We go back to our Ninja player. And probably at this point now, so once we've done that animation where we sort of show the shadow once it's been invisible, we can now try to set this back to 0, because we want, or to that low number that we're using, maybe 0.3. And we can set our new show shadow only to 1. So that should end up creating the exact same effect, but we are setting the opacity back down to it being no longer visible. So now if I press I, we then get that just the shadow being shown at its full intensity, and it's a dynamic shadow. So we can create a bit of when it's animating, maybe adds a few extra keys. So that'll create a slight sort of flashing effect, I think. Before we get the full shadow. So we could play around with that to make it look prettier. So that's going forward. Now, how do we do it going backwards? So when we reverse it and we come through here, we should maybe create another custom event, make visible. And here we want to play this maybe the other way around, isn't it? To go from invisible to visible is in essence just reversing the process, but with a few extra steps. So when we come through the flip-flop to go from invisible to visible, we will call a function called makeVisible. What that will do is, first of all, it will turn off the show the shadow in the material that we're using. I'll put that scalar parameter to 0. Then it will call the opacity change when becoming visible. And that's this function that we've already set up here. And basically, this is how we animate a change in the shadow when we're transitioning from one state to another, so it is not a sudden change. It makes it smoother. I've just changed some of these keys on here, but otherwise it's still from 0 to 1. And otherwise it just sets the parameter value of the mesh opacity, and there's no change on the backwards, which is the reverse from end that we're calling from this function. Then once it's called that function, it has a delay for the timeline to complete. It then unhides the actor, so now it is not hidden, and then it calls the invisible timeline that we're using, but reversing it. And what I've done though is I've just added a combined track instead of having two separate tracks, and that goes from being a value of 1 at 0 to a sort of a value of 0.2 at 2 seconds, and that's just a bit of trial and error to find the right numbers. That then uses the combined value to set the vertical line location. So in the reverse it goes from being at the feet and moves up towards the head, and it just divides that number by 2 to set the mesh opacity, so we get a more clear cut as we're making that transition. And on the reverse one, at the end it just sets the mesh opacity to 1, so it's fully opaque. So that would then do both the visible and the invisible transitions that we're using with these functions. So we can go back and just see how that now looks in our game. So when I press I, we get this kind of transition there. And to become visible again, we get the animation, and then we get the transition. And we can do that while we're walking. And we can become visible while we're moving. So that is the invisible to visible and vice versa changes that we're able to make. And again, a lot of these numbers in the actual character are sort of trial and error to find the effect that you are looking for on these timelines. If we want to manually control these values, we can do so with input actions. So I've created a sort of input mapping context, and I've mapped it to sort of the period and the comma keys to control either the vertical line or the opacity itself. And then I've just added that into the character as an input mapping context on the begin play here. And the functions are quite simple. So basically when we do the invisible input action, that controls the vertical line location just by getting the value and subtracting a number from it and setting it. And the manual mesh opacity uses the input action for the opacity and then controls the mesh opacity just by subtracting a value or adding a value to it. So when we are playing, we can, with the keys, just control the level at which it happens. So we can move it up and we can move it down. We can make it completely invisible, just part of the body. Or we can make it reappear just by using the keys instead of having to do it automatically, which we can also do. So I hope that helps you in creating an effect like this.